Lesson 8.4, we'll be back at 8a. So let's do A. So the quadratic formula is very useful, however, sometimes the calculation is really kind of too much. So that's why we learn how to do without quadratic formula for some problems, so that we can do it easier, or not easier, but the calculation wise it's easier. So let's put the negative aside because it's annoying. So let's put 18x squared plus 65x plus 7. Okay? Then now you look at 18x squared, and it's not really a square number, so we're going to multiply 18. So we have 18 times 18x squared plus 18 times 65x plus 18 times 7. So we can't really do this because we are changing the problem by multiplying by 18. But if we divide 18 at the end, it's not going to be a problem. So we have negative times 18x squared plus 65 times 18x. You see I'm using commutative property to switch around. Plus 18 times x will give us 126. Then we're going to hide the 18 part for now, so that it looks like, h squared plus 65h plus 126. Now it looks more familiar. Then let's keep going from here. So we have, we're gonna use the sum and product theorem to see if we can have any number that adds up to 65 and multiply it to 126. So 126 could be 2 times 63. Oh, here you go. Okay, so we have negative h plus 2 times h plus 63. You see these pair, if you add it you get 65, and if you multiply you get 126. So now put the hands off, so we'll have 18x plus 2 and 18x plus 63. Now I can pull out from left parentheses, I can pull out 2 from 18x and 2. So I'm going to do that. So I'm going to have 2 times 9x plus 1. And also the same concept applies here. I can pull out actually 9 from 18 and 63. So I'm going to pull that out. That's the common factor. Then the leftover will be 2x plus 7. Now if you look at this, right here, we have 2 and 9. So that's actually 18, which we multiplied at first. So at the end we got to do the opposite to neutralize. So we're going to divide 18 by 18. So that's gone. Therefore the answer will be negative 9x plus 1 and 2x plus 7. Okay? Apply that idea for other problems. Problem number 6, this doesn't have anything in front, but you're supposed to factor it. Okay? Factor. You can use quadratic formula, but the calculation is going to get really annoying. So you don't want to do that. So I want you to give you throw out some hints. For problem D, looks exactly like problem C, except the fact that you have x plus 1 instead of x. So you can put the hands right there, like that. Then it looks exactly like C. So you don't really, these two problems are related, so you don't use that as a hint. And for F, E and F is a kind of pair. Okay, and then the G is also, E, F, G are pretty much the same problem, except the fact that for F we have x minus 1 instead of x. for g, we have 12 and 6 as a power instead of 4 and 2. If you have 4 and 2, what would happen? Well, it's pretty much the same thing. Well, for E, it looks exactly like A. So let me just do A and E together. Okay, A, I'm going to use the same concept. I'm going to multiply the entire thing by 4. So that's 4x squared minus 13x plus 3. Okay, then we have 4 times 4, which is 4 squared. 4 squared x squared minus 4 times 13. So 13 times 4x. Well, wait a minute. Let me just do it very carefully. So 4 times 13x plus 4 times 3. Now 4 squared x squared is 4 times x to the second power, and use the commutative property, and then we have 12 at the end. Put the hands on. We have 8 squared minus 13x plus 12. Now this looks like mnemonic quadratic, and you look for a pair of numbers that adds up to negative 13 and multiply to 12, which is negative 1 and negative 12. Put the hands off. And from the right side of the parentheses, we can pull out 4. So we have 4x minus 1 times 4 times x minus 13. Not 13, I'm sorry, 3. Those are the leftover. And we actually multiply the entire thing by 4 right there, so we're going to have to divide that to neutralize. So the answer will be 4x minus 1 and x minus 3. And this problem is, the part is almost exactly like this. Okay? So use the concept. We have 4 times, let's see, 4x to the fourth minus 13x to the second plus 3. And do the same concept. We have 4 to the x, 4 times x squared, 4 squared times x to the fourth minus 13 times 4 times x squared plus 3. And now we can do 4 times x squared to the second power minus 13 times 4x squared plus 3. I mean, not 3, I'm sorry. It's 4 times 3. So that should be 12. So that's 12. And then if you put the hands on, h squared minus 13h plus 12, and it looks exactly like this problem right there. But instead of 4x, we have 4x squared. So that's the only different parts. We have 4x squared minus 1 times 4x squared minus 12. Therefore we have 4x squared minus 1 times, we can pull out 4, and that 4 will be cancelled out, so the answer will be this left parenthesis and the right parenthesis. And apply this idea for problem number 6. Last page, standardized test prep. For what value of x is equation 2x minus 15 equals 1 true? So 2x minus 15 over x equals 1. That denominator is annoying, so we're going to multiply the entire thing by the x. So that x times 2x will be 2x squared minus 15 over x times x. Long story short, that's 15 equals 1 times x. Now we need 0 on the right side so that we can use zero product property. So subtract x from both sides gives us 2x minus x minus 15 equals 0. Now you can solve it by yourself. Solve the equation 2x minus 3 over x equals 5 for x. So this is pretty much the same problem as number 7, so use the same concept, and once you get this one you can use quadratic formula, or you can use hands on, hands off. That's kind of Karate Kid, if you know what I'm talking about. So, yeah. Good luck. That's it.